Hello friends, welcome to Doubt Forum. This question is, a pendulum consists of a bob of mass equals 0.1 kilogram and a massless inextensible string of length equals 1 meter. It is suspended from a fixed point at a height equals 0.9 meter above a frictionless horizontal floor. Initially, the bob of the pendulum is lying on the floor at rest vertically below the point of suspension. Now what is happening? A horizontal impulse of magnitude 0.2 kilogram meter per second is imparted to the bob at some instant. After the bob slides for some distance, the string becomes taut and the bob lifts off the floor. The magnitude of the angular momentum of the pendulum about the point of suspension just before the bob lifts off is j kilogram meter square per second, and the kinetic energy of the pendulum just after the liftoff is K Joules. So we have to find the value of J and K. So one thing which we have to keep in mind is that the value of J is just before the liftoff and the value of K or the kinetic energy is just after the liftoff. So let's draw the diagram for this question. Suppose this is a frictionless horizontal surface. This is a fixed point or the point of suspension of the bob, and let's assume this is a string. And this is the bob of mass equals 0.1 kilogram. This height is given to us as 0.9 meter. The length of the string is 1 meter, and as we can see that the point of suspension is 0.9 meter, so definitely this string would not be tight and it would be loose somewhere, so it will look like this. And now what is happening? There is an impulse imparted on this bob, and the magnitude of that impulse is given to us as 0.2 kilogram meter per second. So this is 0.2 kilogram meter per second. And due to this impulse, this bob starts sliding over this frictionless surface. So after some time, let's consider that this bob has reached to this point. And now at this point, the string has become taut. So as we can see, initially this string was not taut, but the moment it reaches to this point, this string has become taut. So when this string has become taut, this length would be 1 meter. And because of this impulse, this bob would have achieved some velocity. So let's say it has achieved a certain velocity and its magnitude is v meter per second. So first thing which we have to do here is to find the value of this v. For that what we can use this impulse, because we all know that impulse imparted on an object is equal to the change in the momentum of that object. So impulse is equal to change in momentum. That is the final momentum minus initial momentum. The value of impulse is given to us as 0.2 kilogram meter per second. So this would be equal to the change in momentum of this bob. So initially the bob was at rest. So initial velocity would be 0. And the final velocity we have assumed its value to be v. So this would be equal to m into v, and this term would become 0 because initially the bob was at rest. So this would be 0. So from here the value of v would come out to be 0.2 divided by m. Here this m is the mass of bob and its value is equal to 0.1 kilogram. So from here the value of v would come out to be 2 meter per second. So once we have find out the value of this v, the first thing after that is to find out the angular momentum. So for angular momentum, we all know that the angular momentum is equal to the inertia into angular velocity. Inertia for a single object is given by m into r square, that is the second moment of mass, into this omega, that is the angular velocity, can be expressed in terms of linear velocity divided by r. So from here the formula for angular momentum would come out to be mr into v. Here this m is the mass of the object, r is the perpendicular distance from the axis of rotation, and v is the linear velocity. As we can see in the question, we are asked to find the angular momentum just before the bob lifts off the floor. So this is very important. So in this formula, the value of m is 0.1 kilogram. R is the perpendicular distance. So here this perpendicular distance would be equal to this 0.9 because this is the axis of rotation and this is the bob. So the perpendicular distance from this axis of rotation to this bob is 0.9 meter. So this would be equal to 0.9 into v. V is the velocity and its magnitude is 2 meter per second. So from here, the value of angular momentum would come out to be 0.18 and the unit is kilogram meter square per second. Now coming to the second part of the problem, that is the kinetic energy of the pendulum just after the liftoff. Because we are asked to find the kinetic energy after the liftoff, for that what we have to do? For that we have to break this velocity into its two components. One would be in the direction of this string and the another would be making an angle of 90 degree from this component. So this would be something like this. So if this angle is theta degree, so this angle would also be theta degree. Because if we draw a vertical line like this, so these two lines would be parallel to each other and this is a line which is crossing. So this angle is theta, so this angle would also be theta. And because this angle is theta and this angle is 90 degree, so this part would be 90 minus theta. So this part would be theta degree. Once this is known to us, what we can do, we can simply mark this as v times of cos theta and this would be v times of sin theta. So as we have to find out the kinetic energy just after the liftoff, so only this v cos theta component of this velocity v would be causing the kinetic energy after the lifting off. So what we have to do, we have to simply use v cos theta in the formula of kinetic energy. So kinetic energy is given by half into mv square. So here this would be half. The mass is 0.1. In place of velocity, we have to keep this v cos theta. So this would be v times of cos theta square. The value of cos theta we can easily find out. Cos theta would be base upon hypotenuse. So base is 0.9 and this hypotenuse is 1. So cos theta is 0.9. So this would become half into 0.1. The velocity is 2 meter per second. Here we have just found its value. And cos theta is 0.9 and whole square. So this would become half into 1. This would be 81.25. And if we simply multiply all these numbers, its value would come out to be 0.162. And the unit of energy is joule. So thank you for watching. If you still have any doubt, please let me know in the comment section. See you in the next video. Till then, take care. Bye bye.